Some of you may have come across a presentation by a chap called Brett Victor called Inventing on Principle. In the first part of this, he presents some ideas based upon the notion of writing tools that increase the bandwidth between the programmer and the software on which he's working. In the Smalltalk world, where I come from, it's been commonplace for some time to perform interactive coding and programming in the debugger. But this hasn't been available for more mainstream programming languages, and certainly not for mobile devices. The purpose of this video is to show you how you can do this sort of interactive live coding right now using freely available tools and when programming interactive 2D applications. We're going to be using Gideros Studio, which is a Lua-based IDE and framework, and an interactive open source debugging system called ZeroBrane Studio, which remarkably also supports a fledgling live coding system. So let's get started by opening an example project inside Gideros and preparing it for live coding. Now there are a number of prerequisites you need to talk to the ZeroBrane debugger. You need mobdebug.lua and the sockets library in order to communicate with the debugging server. And you need to make a few changes inside your main.lua. This particular demo requires box2D, so I'm including that here. But the most important thing is to require and start the mobdebug server. You also need an event processing loop to keep the server communications alive. And I've also added an application reset utility function to allow me to clear the stage whenever I need to. Finally, we transfer control to livepad.lua, where we're going to do most of our coding. There's a little bit of setup in here, and I'll come to why we need that later. Now let's start the Gideros player. We're on a real device connected by Wi-Fi, and the next thing is to bring up ZeroBrane itself. First thing to do here is to use the project menu and start the debugging server, and to select the folder where your project files reside. This is my main.lua file, and this is the live pad where we're going to be working. Now I switch back to Gideros Studio and start the application running in the player. We don't see anything happen yet, but if we go back to ZeroBrane, we'll see that we've broken on the require mob debug line. Then we switch back to the file where we're doing the live coding and choose project run as scratchpad. You can see now that that's started the application running on the iPad itself. So let's get started with some live coding. To avoid any artist's block, let's kill the white and set a background color. Now you can see that the live pad has given this integer an underscore, which can be used as a slider, which I can drag with the mouse, and you can see it's changing dynamically the background color. Now it's not ideal to use a single integer for setting an RGB value, so let's write an utility method, RGB, which takes 3 integer values which we can set independently. Now to avoid you having to sit through my rather sluggish typing, there'll be situations in this video where we cut ahead like this and end up with a piece of finished code. Let's go and use this RGB method in our set background color call. We'll set the 3 integer values to give us black, but now we can slide each of these individually to give us more control over the background color. So I've settled on this green background color. Now the first thing I'm going to do is to create a new class called Mechanism, and we're going to use the Gideros Studio class system. But because we're in a live coding environment, we need to make sure that the class is only created once, and we do that with this construct here. Let's write the constructor for our Mechanism class. I think it's important at this stage to get something on screen as soon as possible. So I'm going to load in the Gideros logo as a bitmap. And one of the interesting things to notice is that as we're typing, we're informed of any compilation errors dynamically down in the output window here. So we can see almost immediately whether we've actually made any syntax errors or not. Like, for example, this one here. So we've created the bitmap, and now we need to add it to our self object, the mechanism, and also to add this to the stage. Now we don't yet see anything on the screen, and that's where this restart required button comes in. If we turn it on, then that enables this section of the program, and we can use it to simulate the situation when the program is being started again from scratch. So what we want to do here is to create a new mechanism object, and you'll see that it instantly appears on the screen. Let's now choose a location for it using a set position call. Again, if I use integers, I can use the live code sliders to dynamically set them. And you see this makes it much easier to choose a real location for my object. But I can still choose to do this programmatically if I wish. Let's set our object to a center location using the screen width and height divided by 2. Okay, that doesn't look like the center of the screen. But the good thing about live coding is I see immediately when something's gone wrong. In this particular case, I think I need to set the anchor point of the bitmap. And we get an immediate confirmation that the problem's been fixed. So next up, let's change the scale of the object. Again, we can do this dynamically. But here, if I terminate the number with an extra 0 after the decimal point, I can use it to get finer accuracy with the sliders. That looks about right. That's enough static stuff. So now I'm going to get things moving by adding some physics. We'll create the box 2D world. Standard gravity, and I'll pick an arbitrary scale which we can tune later if we need to. Now I'm using a new Gideros helper library, which among other things makes creating box 2D objects a lot easier, and I'm going to use one of the new simpler calls to create a circular body object that's connected to my Gideros logo. We'll make it a dynamic object. But before we set up anything on the screen, we're going to need to set up an enter frame listener in order to update and to step the box 2D world. Now, one thing you have to bear in mind is if you're intending to do any live coding inside an event callback, then you need to wrap the function in a protected call, which is what I'm doing here. And the reason for this is to stop any runtime errors that occur in the function from exiting the system. It might be possible in future to wrap the add event listener calls automatically, but for the time being we're just going to do it like this. Now, as I complete this update call, I would expect the Gideros bitmap to be under the control of physics immediately. But we don't see that, and it's because we have a small syntax error here. And once we fix that, we see the box fall. Now the program is restarting each time it gets a successful compile, but that doesn't matter, and I'll show you a way of controlling that in a minute. But first what I'd like to do is add a border around the whole screen, which I can do using a terrain object. And now you see that the bitmap is caught at the edge of the terrain. Let me create a new bitmap, this time with the ZeroBrane logo. I'll copy the code we used before. And this time I'm going to use a rectangular physics body, since the ZeroBrane logo is somewhat more rectangular. And when we add it as a child to the scene, we see it immediately appear. I'm going to turn it into a draggable physics body, and you'll see that there's a lot of refreshing as I type. But there is one way to stop that. And the way to do that is to temporarily put a syntax error into the script, and I do that with a dot. And now you see, as I try and turn the Gideros logo to be draggable, as I type there's no refreshing. I can start the refresh again by removing the syntax error, and now you see we get immediate confirmation that both of these items are draggable. Before I go any further, I'm just going to save these two bitmaps as fields inside my mechanism object, so we can use them later. And now I'm going to try and play around with the relative positioning of the two objects. I'll just set the start position of the ZeroBrane logo at 50. The Y position, and the Gideros logo at 400. Now, I haven't done much box 2D programming before, so I thought it might be interesting to play around with some physics joints. Let me get the position of the two logos. Okay, and let's create a joint definition, and in this case I'll make it a distance joint. Now the create distance joint definition method takes physics bodies as its two parameters, so I need to access those off the two bitmap sprites and give it the initial positions, which will set the length of the distance joint. And now we see we have a fixed distance between the two objects set by the length of the joint, and when we create the joint from its definition, we get the ability to move the two around and for them to be linked. So just playing with that gives me an idea. What would happen if we make the top object, the ZeroBrane logo, static? And now you see we can swing the Gideros logo below it. Now one of the nice things about the immediate feedback you get when live coding is that it can inspire you with new ideas. I hadn't thought it initially, but this looks a little bit like a pendulum. So what we can do is set the length of the pendulum and offset the Gideros logo position from the ZeroBrane logo by the length of that pendulum. And we should be able to play around with the period based on the length. So now I've had that idea, let's link the two objects by drawing a bar between them. What I'm going to do is I'm going to create a Gideros shape object and draw onto this dynamically in each frame. But I'm going to mix things up slightly, and we'll start the pendulum swinging, and I'd like to show you how we can make these changes without having to restart the application each time. So let's click on the restart required button, turn that off, and now any changes we make won't require the application to be restarted each time. So let's add some drawing code to the onEnterFrame method that's called 60 times a second. And you'll see what I've done is I've asked it to draw a line between the two objects. And when we make the end path call, you'll see that we get the updating bar drawn between the two objects. But I can see now that my pendulum is hitting the edge of the screen. So let's turn off the terrain object that we created. Because we're making this change in the constructor for the mechanism object, we're going to need to turn back on restart required so that any changes we make will restart the program. And now you can see that our pendulum swings freely. Now before we go on, I'm just going to make a few minor visual adjustments. Let's change the sizes of the objects. That looks good. But I've just noticed that up here the pendulum bar isn't actually centered on the right pivot point inside the cog. So let's make a dynamic adjustment to that. In order to do this, we need to just move this physics line a bit further up so that the anchor point will respond correctly. And now when we set the anchor point for the bitmap, we can adjust it to be over the center of the pivot. Once again, if I add an extra 0 after the decimal point, it makes it easier to do fine adjustments. So we're almost done now, but it just seems like it might be quite a nice idea to make this pendulum actually do something. So let's put a sensor point down below. And what I'm going to do is I'm going to use another object, a bitmap, this time with the Bauhaus logo. And if we position this down towards the bottom of the pendulum, once again we're going to need to set the anchor point to center it correctly. And now we can make the final Y adjustments with a slider. So what I want to do is when the pendulum touches or becomes close to the Bauhaus logo, we'll trigger a tick event. And to do this, we'll need to create another physics object to act as a sensor. Here I'm adding another rectangle. But the problem now is that the Bauhaus logo is getting in the way of the swinging of the pendulum. But there's a way around that. We can make the physics body a sensor so it doesn't get involved in the actual collisions. And now you can see once again the pendulum swings freely. Now we've done that, the final stage is to create a contact point which can inform us when the pendulum touches the Bauhaus sensor. And we supply this with a function to call each time there's a contact between the two. And I'll fill in the blanks here. So what happens is when there's a contact, the alpha of the Bauhaus logo is set down to 0.2 and it's recovered with a tween taking half a second. And also at the same time we dispatch a tick event for any third-party components that may want to make use of this pendulum mechanism. So now what I've done is I've transferred the code we created in the live pad into a separate file, mechanism.lua, and I've cleared down the live pad so we can develop some new code that makes use of our pendulum mechanism. To do this, I've had to restart the debugging session, so I'll start Gideros player again and the program and go into ZeroBrane Studio and start scratching on the live pad file. So we're back with a blank screen, and I thought it might be fun to develop a clock application using what we've already created. So let's create a new class, clock. Once again, this is a sprite because it has an on-screen presence. And in the constructor for this, I'm going to create one of our mechanism components and link it to a clock face. But first, we need to instantiate a new clock. We don't see anything yet because there's nothing in the init method. Let's load up one of our mechanisms. Oh, and just before I saved the mechanism file away, I added a little animation to tween the pendulum in from the side and start it swinging. Now, I already have a clock face component, which I've created previously, so I'll bring that in now. Obviously that's a little bit too large and in the wrong place. And scale it down. And I'm going to relocate it somewhere near the center of the screen. That looks about right. Now all that remains to be done is to link the tick event from the pendulum to actually get the clock to step. And we can do that simply with an event listener for the tick event. Okay, so the pendulum hasn't received quite enough of an impulse, so let's start it swinging manually. And you can see we've now created quite a funky art house style clock, all by the magic of live coding. I found that you can tune this to be quite accurate by adjusting the pendulum length and also the scale of the physics. But right now, let's just change the background color without restarting the clock, and we'll just set it here to solid black. So I hope you've enjoyed this excursion into live coding. What you might have thought was a pie-in-the-sky technology is available right now. I think this could be the start of a new genre of development tools that make coding faster and much more exciting.